Hello everyone. In this video, we are going to talk about the roadmap for the low level design. Now, often there are lot of content available for the low level design and how to go about it. But the problem is that there is no chronological order. Sometimes people directly jump into the interview question, which should come in the last. Sometimes they are just jumbled around the two basic concepts of Java or for loop, while loop, etc. So there is no direct connect that what is the right order to go about the low level programming overall and how to go about it. So I'll give you a roadmap so that you have a clear mind map that what you should prefer to learn first, then what you should learn, and eventually what are the things which you should learn. So if you have that mind map in the right order and you learn the basic concepts correctly, then it will be extremely easy for you to build the complex systems like maybe Sudoku or snakes and ladder, and you will not directly jump the gun and learn the last or the most complex stuff first and then feel underconfident. So let me give you the overall picture of how the low level programming looks like, or in fact the programming overall looks like. So the first thing is that there is a machine level code, and this code actually runs on the CPU or hardwares. So these are generally the binary or hexadecimal numbers like 0, 1, etc. And as a programmer, you will not have to deal with all of these any time. The second is, if you move a slightly one level up, there's an assembly language. And this is something which you would have studied in college and then forgotten about them. So here you have to write too much of code, and they are quite low level code. By low level, you mean that you have to deal with registers, and in fact, to compare two number, you have to, copy a value to a variable and then eventually compare those two variables. So a lot of code is written there. And as a programmer, you don't have to deal with it. So for the programmer, generally, this is the starting point. That is, any programming language like Java, C++, C Sharp, etc. This is the starting point for all the things which you do. Then once you learn this, all the Java, C, C++, any of these languages, then you move to a higher level that is called as the object-oriented concepts. So object-oriented concepts are like inheritance, encapsulation, polymorphism, abstraction. So we'll talk in detail about all these concepts, but to talk about all these concepts, you should have some idea of the languages like C, Java, for loop, etc. So if you do not have the idea of these languages, this will be very complex for you and you will be always confused. So have some idea of these languages, and I found a lot of videos and lot of written content also available to learn the basics of these languages. So just have a touch and taste of those and then move to the object-oriented concepts. And then once you learn the object-oriented concepts like inheritance, encapsulation, etc., and learn the fundamentals of object-oriented concepts and principles, then you can talk about the design patterns. So you see the design pattern comes at the last. If you directly jump the gun and read about the design pattern, you will be confused. All you will do is just by hearting the patterns, and nobody is going to ask you, hey, can you write me the code of a composite pattern? Nobody asks us that. Everyone asks us the question that can you design a calculator? And the calculator might be using composite pattern. So it's always the other way around. People give you a problem statement, or in your work as well, you get a problem statement that, hey, you have a object and you need to transform that object to some other object. So these things come into picture in your work as well as maybe somebody asking you. And all the time the questions are asked in terms of problem statements. Nobody asks you, can you write what is encapsulation, inheritance, or can you write this design pattern? So once you are aware and once you are confident in design pattern, then you can move around the problem statements. And the highest level is the system design. So This is how the overall chronology works. For a programmer, they generally start from this level. These two levels are generally not needed. Always good to know, but something not needed much. So for the videos which I'll be keep on posting in the coming days, I want to make sure the audience, the intended audience is very clear. So the first thing is that I'll be posting tutorials in Java. Although I would say that if you are confident in any of the programming languages like C#, even then you will be able to understand everything and you will not have any problem. The second thing is that I expect you to know some of the basics of programming languages. I at least expect you to know what is public, protected, private. I expect you to know what is object and what is class. Any theoretical knowledge is also enough, and you should be able to run a basic program of Hello World in Java. I'm not going to help you in how to install Java. You can find tutorials and you can get those things done. I would also expect you to know the operators, plus, minus, etc., if, else, loop, and a little bit of list and map. So I don't want you to know very detailed concept, but at least at the surface, you should be able to run a Java program. You should be able to run for loops. You should be able to create objects. So if you know these basics, then I think you should be good to go for the object-oriented concepts. And there are a lot of videos where you can learn about these concepts. These are fairly straightforward. So you should definitely learn about them and then move to the next level. So this is how my structure of the course would be. I will not cover the basics of a programming language, that is basics of Java. That is something I expect you to know already about. And as I already told, it is not much, just for loop, just a bit of understanding of the new keyword. That's it. Then I'll talk about, this is the first thing which I'll talk about. It's the basics of object-oriented principles. So here we will talk about encapsulation, inheritance. In fact, there is a principle called a solid principle. So a lot of fundamentals of object-oriented programming. So, and how to think about the problem statement. So if you know the basics, then we will move to the design pattern. And eventually we will look into the low-level design, which are generally asked, or which is something which you generally deal with. So most of the time people will not ask you to by heart a particular design pattern. Most of the time they will give you a problem statement, but that would come in the last. So first we'll make ourselves strong in this. Then the second thing is around the design patterns, and then we'll move into the problem and solution mode. So this is the overall structure, which I think if you go through, it will help you to have a right mind map. So I'll keep on posting such videos in the coming days. Make sure that you understand the right chronology. If you like this video, please like and comment. It really makes a difference. Till the next time, bye.